Alright, so finally here is the answer to Adam's question. Combustion analysis of a compound that contains carbon, hydrogen, and oxygen. What they do is they take two different samples of the same compound. The first is 22.109 milligrams is what Adam's problem said, but I'm just going to write grams because they gave you everything in milligrams. Now if you have 22.109 milligrams of the compound and it produces 39.386 milligrams of carbon dioxide upon combustion, then if you have 22.109 grams of the compound, you will produce 39.386 grams of carbon dioxide upon combustion. The ratio is exactly the same. Since most people are more comfortable dealing with grams, I'm just going to write it all as grams, get exactly the same answer. So what we're going to do is we're going to look at the first sample. Here they tell us how much carbon dioxide, how much water were produced, which means we can find moles of carbon dioxide and thus moles of carbon and thus grams of carbon. From the water, we can get moles of water, moles of hydrogen, grams of hydrogen. So we know how many grams of carbon and hydrogen are in here, in 22.109 grams. Now, okay, we still have sulfur and oxygen left. This is why they gave us a second sample of the compound. This weighed 33.565 grams, the compound. It underwent combustion analysis, and this time what they did is they captured the sulfur dioxide instead of the carbon dioxide in the water. And they tell us that from 33.565 grams of the compound, they got 14.507 grams of sulfur dioxide. What we'll do with this is we'll change the grams of sulfur dioxide to moles of sulfur dioxide, to moles of sulfur, and to grams of sulfur. Now, we'll know how many grams of sulfur there were in 33.565 grams of the compound. And all we have to do is take the grams of sulfur in 33.565 grams times the grams in this first sample, 22.109 grams, and that'll give us the grams of sulfur in this compound. I'll show you. All right, so here, let's get started. This is how much carbon dioxide was produced from 22.109 grams of the compound. I'm going to divide by the molar mass of carbon dioxide to get moles of carbon dioxide, and then because there's 1 mole of carbon in every 1 mole of carbon dioxide, I'll get this many moles of carbon, 0.894943 moles of carbon. Then, multiplying by the molar mass of carbon, we get the grams of carbon in 22.109 grams of the compound, 10.7488. I circle the moles of each element and I make a box around the mass of each element because we're going to need those numbers later. Now looking at the water, 16.123 grams of water produced, divided by the molar mass of water, times 2 moles of hydrogen per 1 mole of water, gives us moles of hydrogen, 1.78992 moles, circle that, times the molar mass of hydrogen gives us grams of hydrogen. Put a box around that. Now let's look at the sulfur. So we know at this point, in 22.109 grams of the compound, how many moles and how many grams of carbon and hydrogen there are. Now we're going to take the sulfur, the sulfur dioxide that came from the 33.565 grams of the compound, 14.507 grams of sulfur dioxide, divide by the molar mass of sulfur dioxide times 1 mole of sulfur per 1 mole of sulfur dioxide gives us moles of sulfur, 0.226446 moles of sulfur. Multiply times the molar mass of sulfur, 32.065 grams per mole, and we get grams of sulfur. But this is grams of sulfur in 33.565 grams of the compound. We want to know how many grams of sulfur there were in 22.109 grams of the compound. So all we do is take the mass of sulfur in 33.565 grams of the compound, divide by 33.56 grams of the compound, times the mass of the compound we're interested in, 22.109, and this will tell us how many grams of sulfur there were in 22.109 grams of the compound. The reason we can do this is because the ratio of the mass of the sulfur to the mass of the compound is the same. It doesn't matter how much of the compound you have. So we have grams of sulfur, there's a box around it, divide by the molar mass of sulfur, gives us moles of sulfur. Circle around it. At this point, We know in 22.109 grams of the compound how many grams and moles there are of carbon, hydrogen, and sulfur. Now we need oxygen. What we're going to do next is this. Let's get it in there. Let's look at this first. All right. We're going to take in 22.109 grams of the compound. We know how many grams of carbon, hydrogen, and sulfur there are. We add them up. We get this many grams of carbon, hydrogen, and sulfur. Subtract that from the total mass of the compound, 22.109 grams. And that tells us how many grams of oxygen we have in 22.109 grams of the compound. Take the grams of oxygen, divide by the molar mass of oxygen, and we get moles of oxygen. Circle around that. We don't need to mass the elements anymore. Now all we need are the moles of each element in the 22.109 grams of the compound. We're almost done. Now to get the empirical formula, all we do is divide the moles of the element that has the smallest number of moles into the moles of all the other elements. It ends up that that's sulfur. 0.149158 moles of sulfur is the smallest. Divide that into the moles of carbon. We get really close to 6 moles of carbon per 1 mole of sulfur. So we round to 6. 6 carbons, 1 sulfur. Moles of hydrogen divided by moles of sulfur, we get 12 moles of hydrogen per 1 mole of sulfur. Moles of oxygen divided by moles of sulfur gives us 2 moles of oxygen per 1 mole of sulfur. Now, finally, we have the empirical formula. There are 6 carbons, 12 hydrogens, 1 sulfur, and 2 oxygens, C6H12SO2. I hope you could follow that, and it was helpful.